Again, what's up, guys? Let's discuss about capacitance in this lecture. Coming lecture, I'm going to discuss on the effect of defibrillators as well. But for this lecture, uh, bear with me with the capacitance, and yeah. So another video of capacitance will be come uh, quite soon for solving the conceptual as well. But for theoretical part, we have to discuss the capacitance, how it works. All right. So to get the prior knowledge of it, okay, let's start. The capacitor is a device that can store electric charge and normally consists of two conducting objects, usually a plate or sheet, placed near each other but not the same. For a given capacitor, it is found that the amount of charge Q acquired by its plate is proportional to the magnitude of the potential difference U between the plates. Okay, charge value. How can you find the value of capacitance when given a charge and this one capacitance and this U? What does it denote? U. I will see. In general, depends on the charge and. Okay, all right, all right. But in Indian uh, literature, capacitance is denoted by C equal to Q epsilon naught A by area divided by D. This is the formula of a capacitance in Indian author, and I think for relation of capacitance and charge, let's see. Okay. Okay. Let's see. So capacitance does not, in a general, depend on Q or U. Okay. All right. Okay. The capacitor is the device that can store electric charge. All right, it can store charge and normally consists of two conducting objects, usually plates or sheet, placed near to each other but not touching. All right. Of a given capacitor, it is found that the amount of charge Q acquired by its plate is proportional to the magnitude of the potential difference V or U between the plates. All right, all right. I know it. For its plates, how will you define or how will you calculate the value of capacitance value of its plate? What you're gonna do is simple. It is the found that the amount of charge Q acquired by its plate is proportional to the magnitude of the potential difference between the plates. Okay, there will be a potential difference between this separation of two plates. So how will you define or how will you calculate the value of capacitance is simply this is capacitance denoted by C equal to charge and the separation between the two capacitance of their potential voltage must be divided by V. So capacitance equal to charge divided by potential difference. Then it comes out to be All right. So then the constant proportionality C is called the capacitance of the capacitor. The unit of the capacitance is coulomb per volt, and this unit is called farad. Coulomb per volt is considered to be farad. All right, is denoted by F. Okay. So as I said this, uh, the capacitance does not, in a general, depends on Q or V. Capacitance C does not always depend on the charge of the separation of two, the charge of its two plates and the potential difference between the two plates. It basically, majorly I must say, depends on the size, shape, relative position of the two conductor, and also on the material that separates them. For a parallel plate capacitor whose plate have a area A and separated by a distance d here, the capacitance is given by this formula. Capacitance C is equal to epsilon naught A divided by distance of separation between them. So we can say that C capacitance is directly proportional to area but inversely proportional to distance of separation between them. So if the separation of two capacitor plates, if the distance of separation between the two capacitor plate is high, then capacitance of the net capacitance between them should be much less. And if the capacitance of two capacitor plate separation has their own surface material are of greater area, then the capacitance also increases. All right, that is the main idea. The simple capacitor consists of a pair of the parallel plate of area A separated by a small distance d. Sorry. Epsilon naught is the proximity of the free surface. Proximity of the free surface, it is the permeability, I must say, permeability of the free surface. So permeability is the allowance of the electric field, whether it is going to be smoothly allowed or whether it is going to be some hindrance. It all depends on value epsilon naught. All right, so epsilon value is constant value, but property must be hindrance or smooth allowance, but it has a constant value of 8.85 into 10 to the power minus 12 coulomb square by Newton meter square. All right. So after that we are going to learn the value of its dielectric constant, dielectric strength of its material. All right, so let's take let's continue. Capacitors are widely used in electronic circuits and sometimes are called condenser. Capacitors store charge for later use. Use of camera, flash, energy backups in device like computer if the power fails, just like our small like what does that call, power backup. It has a capacitor also blocks surge of charge and energy to protect circuit. Also it helps in the protection of the circuit. All right, every tiny capacitor serves as a memory for the ones and zeros of a binary code in the random access memory RAM of the computer and other electronic device. So with the notation of 1 and the 0 of the um, logic gate system. Capacitor has a can be uh, assembled into 0 1 format. And then in most capacitor there is an insulating sheet of a material such as paper or plastic called dielectric between the plate. This serves several purposes. First, dielectric breaks down, allowing electric charge to flow less readily than air, so higher voltage can be applied without charge passing across the gate. Furthermore, a dielectric allows the plate to be placed closer together without touching, thus of allowing an increased capacitance because D is smaller. Thirdly, it is found experimentally that if the dielectric fill the space between the two conductors, it increases the capacitance by a factor epsilon, known as the dielectric constant. Thus, the parallel plate capacitor is simply denoted by C equal to epsilon and epsilon naught into area and divided by the distance. First, the electric breaks down, allowing electric charge to flow less readily than air, so higher voltage can be applied without charge passing across the gate. Furthermore, a dielectric allows the plate to be placed closer together without touching, thus allowing an increased capacitance value. Sorry, because D is small. Thirdly, it is found experimentally that it is if the dielectric fills the space between the two conductors, if the increase the capacitance by factor epsilon down, then dielectric constant, thus the pair plate capacitor epsilon naught by T, where epsilon is the called permeability of the metal. It is the permeability of the metal. Okay.